All right, another one of these composites of trig and inverse trig, right? We're going to start this one off the same way we start everything else off. If we're working from the inside out and we see that this is an inverse trig expression, right? What are the inputs? This 1/4. What is the input to an inverse trig function? It's either, in this case, the adjacent side over the hypotenuse, right? This is inverse cosine. So SOHCAHTOA, right? Since we're doing inverse cosine, it's this cosine is adjacent over hypotenuse. So this is either an adjacent over hypotenuse ratio, or because it's cosine, when we use the interpretation from the unit circle, it's an x coordinate from the unit circle. Now, when you look at 1/4, have you ever seen the number 1/4 on the unit circle before? Okay. Think about all the coordinates that we're used to seeing. The denominator is either a 2 or it's a whole number of 0 or 1, right? So meaning we see 0 sometimes, we see 1 plus or minus 1/2, plus or minus radical 2/2, plus or minus radical 3/2, and plus or minus 1. Those are the only coordinates that we see from the unit circle. 1/4 doesn't fall into that list. So we're not going to be using the unit circle to do this problem, right? We have to use this as an adjacent over hypotenuse ratio on a right triangle. So draw my right triangle here. So what we're saying, and again, this problem isn't done until we've taken the tangent of the output of this statement. So what is the output from this statement? What is the output of an inverse trigonometric expression? It's an angle, right? So this problem will be done. We will have evaluated this when we take the tangent of an angle. How do we take the tangent of an angle? Well, since we've already established that we're doing right triangle trig with this problem, we're going to take the tangent by using an opposite over adjacent ratio. Okay, so do we need to know what theta is? We don't, because we're going to use this one right triangle to help us solve this. So when we draw our right triangle, and I highly encourage you to do so, I don't know how, I mean, you'd have to have some pretty high processing power to do it without a picture, I think. What this statement is saying is that there exists some angle that has a cosine value of 1/4. What angle is it? It's here. And the adjacent side over the hypotenuse is 1/4. Now, to finish this problem, to accomplish this task, take the tangent of this angle. Well, the tangent of this angle is the opposite side over the adjacent side. So I know half of my answer already. The adjacent side is 1, but I don't know the opposite side. So how do I figure this out? Pythagorean Theorem, 1 squared. So I'm going to say P for opposite because I don't want to use O. O looks like 0. So 1 squared plus P squared equals 4 squared. So we get 1 plus P squared equals 16. P squared equals 15. P is equal to the square root of 15. Now, this doesn't come into play in this problem, which is nice. But technically speaking, when we take the square root of something, we have to use positive and negative outputs. But since the cosine value is positive, where is cosine positive for an angle? It's positive in quadrants 1 and 4. Okay. So when we get our answer to the tangent of this angle, and we've labeled both of these as positives, we're going to assume that the tangent is also positive. So we get the square root of 15 for our final answer here. We don't have to say it's negative. It's a little tricky. Remember that there are certain values like cosine, sine, cosine, and tangent are all positive here, right? Over here, cosine is negative, sine is positive, and tangent is negative. We did a grid that had all of those different signs, positives and negatives, and values there. I'd encourage you to go have that out when you're doing this problem. The real trick though is just making sure if this was negative, label one of these sides as a negative if that's the case, right? The hypotenuse won't be negative, but one of these sides could be, right? We did that in this problem, right? When this was negative, we said, well, I'm going to label this as negative radical 3, okay? Because that's the negative value in this problem. So there's ways that we got to see that that relationship between a positive and the negative side length as it relates to this. Okay. All right.